Assalamu alaikum rahmatullah. In this video I shall discuss about a basic part of metallurgy, and you know that student of English versions and Cadet College, those who are watching right now these tutorials, you know that in your chemistry book there is a chapter about mineral resource, metal and non-metal. So in this particular segment of or the chapter of your book, you need to study about metal extraction, what is minerals and ores, and some process of electrolysis and some sort of like non-metal properties. So before going to deep digging of this chapter, we need to understand first what are the steps of metal extraction. And I know that student of you, those who already read the chapter, you know that this is a very complex process, and you know that some metals have different properties. So there is no specific type of metal extraction process for every single metal, but there are some differences. So in this tutorial I'm just focusing on that steps that how the metal extraction is done. So before going to explain these, we need to know some word. What about metallurgy? So metallurgy is a field of study of chemical engineering for those are actually deals about the properties of metals and non-metals. So when we'll study about it, we need to know what is minerals and what is ores. So minerals are the substance which contain metal and non-metal. It can be underneath of the soil or even above the soil, because you know that in Cox's Bazar there is a sand where you can find zirconium. Even kaolin is found in the above of the surface, but you won't find sulfur above of the surface. You need to go underneath the soil. So simply we know that minerals are the substance where we can find the metal and non-metal. But one thing, from where we can find the minerals, from where we can find the metal and non-metal, which is cheaply, we can say profitably and easily, though it's not the right word, easily is nothing doing it. So easily, those minerals are known as ores. Ores, like think about galena. If you know about it, galena is ores of lead, which is lead sulfide, because from these minerals we can find profitably and we can extract profitably this lead. So that is why galena is the ores of lead. But think about the bauxite, that is Al2O3.2H2O. This is the formula of bauxite. This is minerals, but it's not the ores of aluminium, because we cannot get aluminium profitably from these. We need to do some chemical process here. So the concept of minerals is that the substance where you can have the metal and non-metal, but from those minerals we can extract the metal or non-metal cheaply, or even you can say profitably and easily. That minerals is known as ores. And the place where we can find these minerals, these are known as mines. Mines is the place where we can find the minerals. So you need to know three things simply. Number one, minerals. What is ores, and what is mines? So you know that in this chapter it was actually explained that the definition of minerals, because this is very common in a question paper, that they write down the definition of minerals or even ores and mines. So this is the place where you can have minerals. Minerals is the substance from where we can have metal and non-metal, and the ores are the minerals from where we can have the metal easily and profitably. Okay, so now let's jump into the main topic of this lecture, is metal extraction. So we need to know what are the steps of metal extractions. Before going to explain, we need to know one thing, that there are 5 steps of metal extraction. Though it's not finalized and generalized for all metal, we know there is some differences in case of properties of metals. So as there are some differences of metal properties, there are also some differences to extract those metals from their minerals or ores. So metal extraction steps. Number 1, crushing. So as you know that this is an industrial concept, so in the industry it's not a small thing, it's a big thing. So as it's all about economic factor, so an industrialist and those are working for these extractions, they need to think about the economic factor, they need to think that the profitable business. And so when they will search for any metal or non-metal from the minerals, it should be first extracted from the underneath of the soil, and then that to be crushing, that to be grinding. So first step of the metal extraction like that, we need to crush it or grinding it, and for that we need 2 types of crusher. Number 1 is jaw crusher, you know that jaw crusher to make it pieces, and then ball crusher. So by the jaw crusher, these are the big machines, huge machines, and I mean crusher means, you know, grinding, so make it a piece of small particles and mix powder. So by the jaw crusher, the ores that is extracted from the underneath of the soil that has been crushed, and by the ball crusher it's again crushed like a powder. Then the second step is condensation. Condensation is, you can say this is one type of initial purification. You can say this is initial purification. So what is condensation of ores? There are some steps or there are some process of doing it, because it depends on the minerals that has been extracted and that has been crushed. First, you think there are some 4 types of condensation. So basically condensation is purification. I mean, you have crushed, you have made small pieces of your ores, now you need to purify it, because with those ores some impurities, you know that some ores, there are some impurities mixed with the ores, and these impurities can be sands, can be rocks, can be some titanium oxide and some other impurities. So we want only the metal or non-metal. We just only want those metals, but we don't want these impurities. So we need to purify those metals with removing these impurities. So how to do it? Number 1 process is hydraulic process. So actually it would be like hydrolytic process. So hydrolytic process is hydrolytic process. So what do you do? I mean, in case of hydrolytic process, there is an inclined position of machines where these ores that has been crushed will be flowing through this way with water. So when water mixed with these ores will be washed away in this way, it must be one simple basic formula, that is the ores and impurities should have a different density. It might be that ores are heavier, impurities are light. So when the water will be washed through this process, in these grooves, this is the grooves, in these grooves the ores will be stored and the other impurities will be washed away. But if the impurities are heavier and ores are lighter, then in these grooves impurities will be stored and the ores will be washed away. But usually what happens through this hydrolytic process, the impurities, those are like impurities, sands and rocks are washed away with the water, and in the grooves these ores is being stored. So in one process, this is condensation. So condensation is the purification of the ores, and this is initial purification. So we are trying to remove these sands, rocks and other impurities. The second one is froth flotation. Usually it has been done with the sulfides ores. Sulfides ores. Why? Because sulfides ores, there's actually, those ores will have a hydrophilic characteristics or hydrophobic characteristics. Like when, I can explain this in a way. Okay, in froth flotation, what is actually froth? Froth flotation means when we will have a mix of a big tank with these ores, basically sulfide ores. So it has stored with the sulfide ores and water. So when oil is mixed with these, and through a wash, a air blow, if it is shaped, then what will happen? We know that oil is not dissolved with water, so it will be floating, and then it will come to the surface of the solutions. So when we mixing with the oil with the sulfide ores, and then through the shaking process, the sulfide ores with oil will be floating in the upper part of the tank, and in the rest of the part will be impurities. This is impurities. So in this process, I mean the froth flotation process, oil and water is mixed with the sulfide ores, so that sulfide and oil will mix together and come to the surface of the tank, and then it will be separated. So we want that the impurities should be removed. So froth flotation is one process by which the sulfide ores can be purified. Number 3 is magnetic separations. Think about some hematite or magnetite or limonite. Those are the ores of iron. They have characteristics of magnetism. So when wheel process, you know that wheel, a magnetic wheel will be used with a plastic conveyor belt, and then it will be moving with this direction. Suppose in this direction it's moving. Now you see that when the ores will be stored here, and it will be coming in this process, among them those impurities, they are non-magnetic, but the ores are magnetic. So the magnetic separation, this process is used only for those ores are magnetic. Suppose the ores are magnetic and the impurities that I want to remove from the ores, they are non-magnetic. So what will happen when it's coming with a motion? It's circulating, and these wheels is actually a magnetic. Then you know the ores are coming, so when it will come to this point, this will attract to this point also, but when it will come to here, the magnetic ores will be stored like this, and the impurities, those are not magnetic, through the motion inertia they will come to this way, and they will be stored in this bucket. So we can separate the non-magnetic impurities with this process and the magnetic ores here, and this is known as magnetic separation. So the magnetic separation is used only for those ores are magnetic properties through this wheel process. So these wheels are actually magnetic, and the non-magnet will come in this way because they do not attract with this wheel, but the magnetic ores will come to this way. So this is magnetic separation. there are some other ores where these three process is not actually applied because of they will have some chemical properties. Basically, in case of bauxite ores, I mean, it's not actually ores from minerals. When we want to have aluminium, the chemical methods is applied. I will explain these chemical methods when I shall explain the extraction process of aluminium, because it has a huge thing I need to explain. So the chemical method is another type of condensation process of aluminium oxide, and this is applied for only for that. So condensation of ores is an initial purification of the ores when we want that impurities, and those are impurities should be removed by the process. So there are four processes. Hydrolytic process, by which we can say that this is the hydrolytic process where there is a groove. So this is number one. So the ores will be washed with water. So the impurities will come with water, and in this groove, the ores will be stored. So this is number one. Second is flotation. So we'll mix with oil and water and then shake with the air blown, and then after what will happen, the sulfide ores will come up in the surface of the tank, because it will add with oil, and oil is lighter than water. So in the water with mixture, the impurities will be there. In case of magnetic separations, we use this way because of magnetic properties of ores. Those have magnetic properties, they will be separated from the impurities in this way. So you have done the crushing through the jaw crusher and ball crusher. Then you have done with the condensation, which is the initial purification of the ores, and then you need to do the conversion of these ores into oxides. So how we can make these oxides? We have two processes. Number one is calcination, and number two is roasting. So what is calcination? Basically, calcination is done with the carbonate particle, and roasting is done with the sulfide particles. So usually we can say that this can be done in carbonate and this can be done in sulfide. So what is calcination and what is roasting? Calcination is the process, I mean, you need to heat the ores below its melting point, It's one thing is important, that the heat temperature, the absence of air. So think about it, the calcination process. Number one, calcination, and it's roasting. What about the calcination and roasting? Number two is roasting. Think about it. In case of calcination, we can say that zinc carbonate and calcium carbonate. Zinc carbonate and calcium carbonate. If you heat without the absence of oxygen, then it will turn into zinc oxide and carbon dioxide, calcium oxide and carbon dioxide. So you are turning the metallic oxides with calcination. So the calcination is the process of heating the ores in absence of air, because there can be a moisture and some other thing that should be removed, but it should be less than its melting point. And the roasting is for the sulfide, like lead sulfide and zinc sulfide. If we heat it with the presence of oxygen, then it will turn into lead monoxide and sulfur dioxide, zinc oxide and sulfur dioxide. So this heating process is done with the presence of oxygen. So the difference between roasting and calcination is calcination is done in absence of oxygen only for the carbonate, and below the melting point. So when it is heated below the melting point, in absence of oxygen, then it will break down into zinc oxide. That I want to make the conversion of ores to oxides, so I want these oxides, oxides and oxides. But in case of sulfides, it has to be done with the presence of oxygen but below the melting point. So we'll have the oxides, because in this step number 4, step number 3, we want that it should be an oxide. Number 4. Now we need to remove this oxygen, and this removal of oxygen is known as reduction, because we know that reduction is the removal of oxygen, and this reduction can be done in 3 processes. Number 1, electrolysis. Number 2, carbon reduction. And number 3 is self-reduction or auto-reduction. What about that? In number 4 step, number 3 you have done what? Calcination and roasting. In number 4, now you need to do what? The reduction of oxides, because you converted the ores into oxides. Now you will do the removal of oxygen, and that is reduction. So this is step number 4. In step number 4, the main process number 1 is electrolysis. So you know that in electrolysis there is an anode and there is a cathode will attached, and these should be the ores in the molten stage. But before going to study that, you see this series, this is the reactivity series of metal. I will explain it later on, but for now I'm just giving an idea that these metals are highly reactive metals, and if you want to remove oxygen from their like Al2O3, this is bauxite. If you want to remove this aluminum oxide for this, you won't be able to do it with carbon reduction, because carbon cannot reduce them, because they are really active metal and their oxides are strong. So for removal of these oxides, we need to use electrolysis. So the positive ion will go to the cathode, and negative ion will go to the anode, and then it will be separated. But for this process, like zinc oxide, think about zinc oxide, cupric oxide, lead monoxide. So if you use, or iron oxide, if you use carbon in all cases, then carbon will remove these oxides, as because carbon is a reducing agent. So this will be done, this will be done. So the zinc will be separated and carbon will be monoxide. So copper will be separated, or lead will be separated, iron will be separated through this process, because they are moderate level active metal. So when we'll have the oxides of this type of, moderate level active metal, we can use carbon reduction. In other cases, silver sulfide. So silver sulfide is less reactive. So when we use only heated them with oxygen, then silver will be out, and we got silver and sulfur dioxide. So here carbon reduction is not required, as silver is less reactive metal. In this case, those are moderate level or mid-level reactive metal. For those, for oxides, when we want to reduce these oxides, we can use the carbon. But the less reactive metal, we can only heat them with oxidants and we'll have the metal. But in these highly reactive metal, we need to do the electrolysis. So step number 4, we did in step number 3 the oxides, and in step number 4 we remove the oxides, reduce the oxides. So that reduction is done through the electrolysis, carbon reduction and auto reduction. And last of all, when you got the metal alone, you need to know that this metal is not purified. It can be 90%, 92% purified, but not 99% purified, or even copper. You get only 90% purified copper after the fourth step. So if you want copper 99%, then refining or purification is required. So the purification is done through the electrolysis process like this. So I have only discussed the primary level explanation here. So you need to memorize one thing, that we are extracting metals or non-metals from the ores. So ores is the mineral of that metal or non-metal. So whenever we want sulfur, whenever we want iron or lead or aluminium or whatever, we need to know that first we need to crush those ores. After crushing, we need to condensations the ores through four processes: hydrolytic process, magnetic separation, flotation, and chemical process. Then after, when we have done the initial purifications, we need to make it oxides, and for making oxides we can do the roasting and calcinations. And after doing the oxides, we need to do it reduced. We need to remove those oxygen through three processes. Number one is electrolysis, number two is carbon reduction, number three is auto reduction. And then after you got the metal, then you need to think this is not purified properly. Then you need to purify it through the electrolysis process, and I shall discuss this electrolysis process later on, because there is a different topic, that copper purifications. On that part I will discuss it completely. So stay tuned with me, and I have just explained the primary idea of metal extraction steps. Take care, stay well, see you in the next tutorial with sodium extraction, magnesium extraction, aluminum extraction and iron extraction. Thank you so very much.